Greetings, my young Padawans. Okay, yesterday, the video and what we talked about in class today was trig equations, solving trig equations, and the majority of what we did yesterday was all in degrees. Well, today we're going to be in radians, and as you can see, the first three words of the directions say use a calculator. So you're going to need this guy again. Make sure you turn him on. Go ahead and, what in the world? Alright, let's go ahead and put his mode into radians. Okay, quit. So I'm going to need him, keep him handy. It says use a calculator to find all the angles between 0 and 2 pi that satisfy this equation. Round your answers rather to 3 decimal places. So just like yesterday, if this was an equation, like just a regular algebra equation, 5 cosine theta equals -1. So the first thing I'd do is get my cosine theta by itself, right? So I got cosine of theta is -1/5. All right, so from here, let me zoom in on this just in case you're watching this on a mobile device. So I got cosine is 1/5. So from here, I come up with alpha, which is going to be the inverse cosine of 1/5. Remember, I ignore the negative for right now. So I'll grab a calculator, and I'll show you this one for the first time. Inverse cosine, second cosine, 1 divided by 5. 1.369. So that's 1.369, and those are radians, right? That's actually an angle. So I come up with alpha, then place it in the quadrants. Those two steps, extremely important. 2 steps, first come up with alpha, second place it in its quadrant. So I came up with alpha, now I'm going to place it in its quadrant. All right. So from here, you've got 5 cosine, or excuse me, you've got alpha is 1.369, and it says up here that my cosine value was negative. Well, where is cosine negative? Here and here. That means that this angle is 1.369 radians, and this angle is 1.369 radians. So notice those are both going off of pi, so theta, my angle here is going to be pi minus 1.369. That'll give me my second quadrant angle, and then pi plus 1.369 gives you your third quadrant angle. So you grab your calculator, and when you do these, you type in, just like it says, pi plus 1.369, pi minus 1.369. So my first answer is 1.773 if I round up. My second is 4.511. 1.773 and 4.511. Not too shabby, eh?
None too shabby at all. None too shabby.
Okay, let's do another one. Let's do 2. 2 says 3 minus cosecant of theta is 7. So first off, subtract your 3, subtract your 3. Negative cosecant of theta is 4. Divide by -1. Cosecant of theta is -4. Now I can't leave it like that because there is no cosecant button. I needs the button, and there is no button. So I'm going to change it to sine of theta is the reciprocal of this, -1/4. Now we come to the conclusion of the matter. So alpha is the inverse sine of 1/4. Remember, forget that it's negative. If you plug in a negative number right here, you will get the wrong answer. Let me show you what I mean by that. I'm plugging in the inverse sine of 1/4. Wow. Look at the difference between the inverse sine of negative 1/4. See how this gives me a negative value? I am not looking for that. I am not looking for the negative value. This is only one of my answers. So we have to use the reference angle because there are two answers to this thing. So just like I said before, it's 0.253. And then where is sine negative? Down here and down here. So you got theta is pi rather plus 0.253. And then you've got 2 pi minus 0.253. And I've heard a lot of people asking questions about, well, Mr. Ballard, how do you know when you're subtracting from 2 pi, or how do you know when you're adding to pi or subtracting from pi or adding to 0? It goes with which quadrant it's in. And that actually goes back to the very first lesson you learned on reference angles. If it's in this quadrant, first quadrant, it's just the angle you came up with. If it's in the second quadrant, it's 180 minus, or pi minus. Third quadrant, it's 180 or pi plus. Third quadrant, it's 360 or 2 pi minus. It's just the way it works. Grab your calculator, do some numbers and some stuff, and it spits out 3.395 and 6.030. All right. Just a little advice on the old reference angles there. Okay, so let's finish coming up with this one here. 3 secant of theta over 5 minus 1 equals 0. We're going to add 1, add 1. 3 secant theta is equal to 1, over 5. Now, there's two ways you could do this. You could multiply by 5 and divide by 3. That's 2 steps. Or you could just multiply by 5 and divide by 3. Multiply by 5/3, anyone? This goes to this, and you get secant of theta is 5/3. Perfectly okay to do that. Nothing wrong with that. It's just combining 2 steps into 1 because we're lazy mathematicians. That's the way we do things. We still do our work, but we do it to the least acceptable amount of work. Make sense? So cosecant of theta is, flip this, 3/5. So alpha is the inverse cosine of 3/5. And that is going to be equal to, carry the 1, 0.927 rather. And where is cosine positive? It says cosine is a positive value. Cosine's positive here and here. So theta is going to be 0.927. And then, oh, wow, we're in radians. And then 2 pi minus 0.927, which is 5.356 if you round. Bam! All right, I'm gonna try and get this thing in within 15 minutes. Let's see if we can finish this. Last problem. Final round. Find all angles theta that satisfy the equation for 0 to 2 pi. Do not use a calculator? Why you no let me use calculators? That's what I want to use. Wow, I typed in something serious in there. I want to use a calculator. But it says don't, so fine, whatever. I'm telling you, use a calculator. Divide by 2. And you get sine squared theta is 1/2. Now we talked, this kind of sounded Russian. Now we talked about this yesterday. When you have sine squared theta equals to 1/2, First thing you must do is understand sine squared theta is really sine of theta all squared. Most of you may not know, but I have Russian in my family. My great-grandfather's name was Ivan Ruffin, which Ivan, duh. And then Ruffin actually is Russian. It's Ruffin, Russian. Who knows? Fun. We are having good time, yes. Okay, so we square root both sides. And we get sine of theta is positive, negative, square root 1 over square root 2. You know that square root 1 is 1, square root 2, multiply square root 2, which is positive, negative, square root 2 over 2? Positive and negative? Okay, so fine. Where is sine square root 2 over 2? Well, that'd be at 45 degrees. 45. Where else is positive square root 2 over 2? Positive square root 2 over here. 45 degrees. Wow, we are not in degrees. Who let me do this? Pi over 4. Pi over 4. But then you account for the negatives. Pi over 4. Pi over 4. So answers, theta, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Anytime you see do not use calculator, use unit circle. Before unit circle, use U. Oh man, I'm weird sometimes. Hey, major shout out to Coleman, actually, who got the highest grade on the last test. Fantastic job by him. Can't tell you what it is because the whole law thing, you know, not telling students grades, but fantastic job. I will say it was an amazing last unit. Everyone did very well in the last unit test. Well, mostly everyone. Averages were out of this world, so I'm very, very happy with how you guys performed. Major kudos. The number of A's on this last test was just astronomical. It was fantastic. All right, y'all have a good one, and talk to you next time.